I'm gonna start doing this. Sharing. So this is for Math 1220 applied stats for Monday night on November 24th. So we will be going over chapter 11. So 11.1, we did some examples on class last Wednesday. So today we will continue, we'll finish up this 11.1 and do a little bit of 11.2. So when we come to class on next Monday, we will be finish up 11.2 and then start chapter 12. There are two online homework due on Wednesday night, which will be 10.1 and 10.2. And there's only one homework due, I think I put one or two, I forgot. I think I put two homework due on next, I think, yeah. So two homework due on next Tuesday or one, I think. So let me check. I think it's one. I will let you know, but right now I know it's 11.1 for sure is due next Wednesday. We'll see about 11.2. What else? 1, 2. As you know that we don't have class on Wednesday, so please don't come to school on Wednesday. It's Thanksgiving, so we will be seeing each other on next Monday in this case, which is December 1st. So chapter 11, this is where we talk about where you have two categorical data. So this is we talk about categorical data that can be separate them into different cells. It means that we are doing what we call as more than two categories in this case. Because we did we did one categorical variables or correct proportion in chapter 7 and 8, and then we do the two proportions for categorical data. So every time you see category data means proportions in chapter 9. So what happens if you got three or more categorical data in the same proportion? We will be doing this section called 11.1. So this we will be this sampling distribution that we'll be using for chapter 11. If you are doing categorical data that consists of more than two, that sampling distribution is called chi-square distribution. We'll talk about the chi-square distribution. It is a skew distribution, and it can only found from 0 or positive. It means if you look at your graph, it only can be found in quadrant 1. And it does have a degree of freedom. The degree of freedom in this case is k minus 1, where k in this case is how many categories we have. As the degree of freedom increases, you find out that your chi-square distribution is very close to the normal distribution. Okay, so these are the properties of chi-square distribution. We talked about that in our class last time. So if your degree of freedom is, let's say, is 2, you get yourself what we call as a chi-square distribution, means it is skewed to the right. You only this distribution only found in quadrant 1, means it's from 0 to positive numbers. As the degree of freedom increase, the chi-square distribution will be approximately normal distribution. This is when the degree of freedom is getting bigger, like 5 or 8 in this case. Again, k in this case is what we call as the number of categories we have. Okay. For critical, then the rest you can kind of so what we did in this section called goodness of fit test. The short form for this is called GOF, goodness of fit. So for this case, we are the goodness of fit test is testing on a hypothesis that is an observed frequency that is fit on some claim distribution. There are two types of claim distribution. I will point it out to you. One of them is the probability is given. Okay. So sometimes probability can be also written down as percentage. So they give us the probability of percentage is given. So if that probability of percentage is given in the question, then we want to prove that the observed frequency, which is a sample, it is matched with what it is, matched with the probabilities. Are they the same? Sometimes the probability of percentage is not given. They give a ratio, then it matched with the ratio. Your ratio sometimes is written down like 4, 7, let's say 5, 7, 3. let's say you got 3 groups and the ratio between these 3 groups are 5 to 7 to 3. That means that the first group has 5 out of 15. So if they give you ratio, you can change this into percentage or probability. This will be 5 out of 15. I'm going to teach you this how to do this because the next few questions were asking you for the ratio. The 5 came from the 5 that you see in the ratio here for the first group. Let's say that the ratio from, let's say you got 3 candies in different colors. One is yellow, one is red, and one is green, let's say. Okay, so you got a candy and the candy's ratio, you got 3 colors, yellow, red, and green. And let's say the yellow to ratio to green, correct 2, which is the ratio, is between 5 to 7 to 3. That means yellow candies is 5 out of 15. The 5 came up from here. And the 15 is the total of all this ratio, 5 plus 7 plus 3. So that means that this 5 out of 15 is the probability of getting yellow. Okay, again, I'll teach you all this. And then to get the grade one is 7 out of 15. Again, 7 is the middle one, and then 15 is a total. This is the probability of getting the red one. And then for the green one is 3 out of 15. This is the probability of getting the green one. Okay. So this is another way to figure out the claim distribution. So this is what we do here is talking about claim distribution. So it can be written down as 1, if a claim distribution is given us the probability in the question. 2, the question gives us a ratio like what we just did over here between 3 groups. Sometimes it can be more than 3. And then the third one is if the claims say they have a same distribution. Same distribution in this case, that means that your P0 is equals to P1 equals to P2 equals to P3. So that means that all the distribution is the same. Let's say if they are only having 4 category, then it has to be all 25%. The reason why is if they're having the same distribution, means the probability has to be the same. It means that each one of this group is having the same equal probabilities. So we've got 4 groups. As you know, the whole thing is 100%. So 100% divided by 4 is 25%. So again, these are 3 types of questions that you can use the goodness of fit test to test the hypothesis test in this case. Okay. Now, the questions will ask you to find a critical value here. This critical value, make sure you know that it's right tail test here. We don't do left tail or two tail due to the chi-square is skewed to the right. And this, to find the critical value, you do the q chi-square 1 minus alpha k minus 1. This is actually found in number 27 in your RStudio cheat sheet here. So again, you do not need to memorize this. So this is number 27 here. Where's my pound key? There you go. So that means this is found in your RStudio cheat sheet. Requirements. The requirements for doing this, we call it goodness of fit test. Make sure it is randomly selected, or SRS in this case. And then every counts has to have the frequency count has to be in different categories. That means that let's say this candy has yellow, red, and green. That means you have to have an observed frequency on the yellow. That means how many candies are yellow, how many candies are red, and how many candies are green. So you cannot do yellow, red, green, and blue, and then you find out that this pair of candies do not have a blue color candies. So that means the blue is out. So we don't count blue as a part of your category here. If the count is 0, so you have to take it out. Okay, so make sure that you only have a frequency count for each category. 0 is not included in this case. So if the count is 0, exclude the category. Okay, so this is very important. So like what I just mentioned earlier about the color of the candy. So we only got yellow, red, green. We don't have blue, so clear or orange or whatever color that we have. So you only have 3 colors. We only decided these 3 categories. The one that doesn't count, has a count on it, we have to exclude them. Okay. And the last requirement here is make sure that the expected frequency is at least 5. To find your expected frequency, your formula in this case is E equals to NP. This will be the formulas I say you need to memorize. So I think I haven't set up the things that you need to memorize for the finals. Yes, if you remember what we did in chapter 7, 8, 9 on test 2, that is a final, that's a test 2 formula for this. I will add a little bit more when you come back to Monday class in December 1st. This E equals to NP is one of the formulas that you have. Okay. The hypothesis statement, the H0, is going to be the frequency counts agree with the claim distribution. So usually we just, in a more easier word for this case, this one we just use back the claim statement. So as you guys know that when you test hypothesis statements, hypothesis testing, there is a claim statement. So we will be using back the claim statement as long as this claim statement is positive. Okay, this is important. As long as it is positive. Not positive, it is equal. Let's put it that way. So if sometimes a claim statement is not equal, so this is where the alternative in this case, that means for this case, it will be not equal in this case. We don't do less than, we don't do greater than. Okay, so make sure you guys know that we only do equal and not equal. So depending on your claim statement, if a claim statement says equality or it has equal, make sure you put in a now. If a claim statement tests for inequality or not equal or not the same or it's different, then make sure you put it in the alternative hypothesis. And if you usually for your claim statement, you have to write this in English because it is different from last time when you did in hypothesis testing, you write things in math. But if you want to write things in math, then you can. If they're having the same proportion, then your math part of that is going to be this, where they're all having P0 equals to P1 equals to P2. And for your alternative, if you want to write this, is at least one of this probability is different from each other. So the one that I highlight in red, orange, grapefruit color, I don't know what color is that, is used only if you write them in terms of math. But if you write them in terms of English, then you just write the one that I highlight in yellow. But also, this is only used if for null hypothesis if all of them the same. Remember they are the same. If they are in the ratio form, then you just say that let's use the yellow, red, and green again. Py in this case will be exactly the same what we did here. So I'm gonna copy down this. If I can do that, then come on. There you go. There you go. So this will be your claim statement. So your P yellow equals to 5 out of 15. P green, P red in this case is 7 out of 15. And then P green is 3 out of 15. So if the question is not equal, that means the distributions are not equal among the groups here or among categories, then you have to, your null hypothesis has to lay out all the probabilities in each case, which is in this case, Py is this probability and P red is that probability and P green, and continue if the probability are not the same distribution. Again, this is only used when they have a same distribution in this case. Everyone, okay, this again, I just go through this again with everyone. So test statistic is chi-square, or in this case, sampling distribution is chi-square. You do not need to memorize this formula. Again, I'll put this big cross on here. You will use this formula if you don't have RStudio. Okay. Talking about RStudios, this will be the syntax you use in RStudio. Counts equals to C. This is where you use your observed frequency. Okay. And then prob equals to C is where the probability. So again, if the probability is given like this, you have to put in 5 over 15, 7 over 15, 3 over 15. If they are the same, let's say they are 25%, then you put 25, 25, 25, 25%, 4 times. Then you put the chi-square dot test counts P equals prop. So this is the test statistics we have. Okay. So the examples that we did the first example, so I'm not going to go through that, but we start with second example, and the third examples. The statements that you see here is very similar to the statement given in chapter 8 and chapter 9, with the only exception is this chapter, in chapter 11, when you do the chi-square, you require to figure out the critical values. Okay, so is everything the same? You have to actually got 8 steps now, because critical value will be one more steps. You have to check the requirement for step, and then identifying the H0 and H1, the null and alternative hypothesis step 2. Sampling distribution step 3, which is chi-square. Step 4 with critical value now, and then you have to do the test statistics and p-value step 5. Decision step 6, conclusion step 7, and then answer the question step 8. So mostly everything is the same as what you guys learned before, except this question, in this chapter, you have to do the critical values. And yes, I will say that in your test, it will look exactly like this, with the critical values highlight on the instruction. So make sure you guys aware about this. It's not, I will be bold this critical value. So some students forget to find that, then you will get a point gone because of that. And again, so you ask me, where can I find this? You can find in number 27, which is the Q chi-square 1 minus alpha k minus 1. This is your critical value in this case. And again, I just want to point out here is this also found in number 27 in your RStudio cheat sheet, which is, I will show it to you right now. So again, first line is to find the critical value. The next 3 lines is you're going to type into the RStudio to find your test statistics and your p-value. And do not forget that your test statistic is a chi-square, in this case, which is your frequency distribution is a chi-square in this case. Okay. All right, we did the first example on last Wednesday. So today we will continue with example number 2. Okay. Experiments. Before I continue on question number 2, does anyone have any questions for me? So only 2 students today, Julia and Pamela. Anyone have any questions for me here?
Not yet.
Not yet? All right. So question 2 says that experiments are conducted with a hybrids of 2 types of peas. If the offspring following Mendel's theory, this is a famous, I think it's biologist, or genetics, I believe, of inheritance, the seeds that are produced are either yellow smooth, green smooth, yellow wrinkle, and green wrinkle. And they should be occur with the ratio, not ration. So I got a typo here. It's not ratio of 9:3:1. So usually the 9 goes to yellow smooth. Okay. So I'm going to short form this to become YS. Okay. And then green smooth is GS. So we're going to do the probability for this case. Okay. And then this is green at GS, which is the green smooth. And then yellow wrinkle, which is PYW. And then the last one is green wrinkle. Okay. Now they are given in the ratio type of 9:3:1. Okay. So now I need to teach you how to find this using doing a probability, because you cannot put 9:3:1 in your RStudio. So 9 is for the yellow smooth, so that means it's 9, and then you have to add all these numbers. So what is 9 plus 3 plus 3 plus 1? That will be a total of
16.
Anyone? 16, yes. So so make sure you add all this. Okay. And that will give you 16 here. So that means that the probability of yellow smooth is 9 of 16. For green smooth is 3 out of 16. For the next one is yellow wrinkle, which is 3 out of 16. And for the last probability, which is the green wrinkle, is 1 out of 16. Okay. So make sure you guys know how to write a ratio into a probability. Okay. Then this is the one that you have to enter in your RStudio, not the 9:3:1. Okay. An experiment is designed to test Mendel's theory with the result of this offspring. So here comes the result. So that whether you hear the word result means it's your observed frequency. 307 is the yellow smooth, 77 is green smooth, 98 is yellow wrinkle, and 18 is the green wrinkle. And here is your hypothesis testing here. Your claim statement. Use a 0.05 significant level to test the claim that the result contradict Mendel's theory. Okay. What other factors or variables will change the outcome of this claim? Now, first thing is the word contradicts. What do you guys think? Equal or not equal?
Not equal.
Yes. So this means you are doing not equal. Okay. So if you remember last time what we did, yep. Thank you, Julia. That what we did last time in question 1, we are doing the claim statement says fit wells. I mean, this means we are doing equal to, right?
Yeah.
So this question is asking for contradict, not equal to. So make sure that this claim statement belongs to H1. Okay, just want to point out to you that
hypothesis.
the alternative hypothesis. Yeah, so the null hypothesis, you have to change the word to equal in this case. Okay. Now, before we even start doing this, we have to build a table. Okay, so the table looks something like what you just did on question 1. So I will draw a really icky table here. Let's see if I can draw. Okay. So we have, I'm going to use a shortcut here. So we have YS, which stands for okay, like that. YS, which stands for yellow smooth. Okay. And then we have GS, which stands for green smooth. And then we got YW, which is for yellow wrinkle, and we got GW, which is for the green wrinkle. Okay. And then move this a little bit here. And then on the next line, you have to do the observed frequency. Okay, so it's kind of like, it's hard to draw it when in the test, I usually give you guys a table. Observed frequency. Okay, so we call it O in this case. O on the observed frequency in this case for the yellow is 307 based on the questions. Okay. The green smooth has 77. The yellow wrinkle in this case is 98. And the green wrinkle in this case is 18. Okay, so that is the observed. And then we have the probability. Okay, based on the ratio, the yellow smooth is 9 out of 16. The green smooth is 3 out of 16. The yellow smooth is also 3 out of 16. And your green wrinkle is 1 out of 16. Okay, so these are based on your questions here. So the next one you need to do here is to do it finding what you call as the expected value. A short form would be EV. Now again, in order for you to find EV, the formula is N times P. Okay. So for the first one, you need to multiply. You need to figure out what is N first. So for us to figure out N, you have to add all the observed frequency, the O. So if you take out your calculator and you add 307, 77, 98, and 18, you find out that your N in this case is 500. Okay, so you just need to add all these numbers up. So for the yellow smooth one, I'm going to move this a little bit over here so you can. Again, usually it's given in a nicer table here, so you will see, I know it's better to draw. So in order for you to find the expected value for the yellow one, you take the total, which is 500, times with the probability 9 out of 16. So you take 500 times 9 out of 16. You will get 28.25. So this is expected for yellow smooth. 281.25. 281.25. And you have to do the same thing for this four group in this case. For the green is 3 out of, so 500 and times 3 out of 16. This will be 93.75. So this will be 93.75. And this is also same 93.75 because your probability is the same, 3 out of 16 out of 500. And then the last one for the green wrinkle, you have to take 500 times 1 out of 16. That will be 31.25. Okay. So this is what you need to do first, even before you start doing your 7-8 steps of hypothesis test. Questions so far? So we're going to do requirements check here. So the first requirement is SRS. So as I mentioned early on, all the tests you do, no matter it's chapter 7, 8, 9, 10, all the requirements is going to be SRS. And do we have that in this case? Let's see. We're going to look for the word simple random sample in this case. It doesn't say that. So again, you cannot assume it is, so this is actually not met. Okay. I'll just continue working on it. As you know that if one of them does not match, that means the requirement does not match here. So I don't see the word. I don't think I see the word. Okay. We'll just continue. Second one is every categories has a count. Categories has a count. Which we do because there are 4 categories here, and each category has an observed frequency. So I just put down observed frequency. Sometimes they use the word count, but which is the same thing as observed frequency. This one is yes, we met this fellow. And the third one is the expected values has to be at least greater than or equal to 5. This one is also met because you find out that the EV that we just calculate just now on each group is more than 5 or more. So unfortunately, it's not SRS, so this requirement does not met. Okay, I still see some students did not do this in your test, so make sure I take half a point off. Do not do that in your finals again. Okay.
Okay.
Yes, Pamela.
Oh no, that wasn't the question. I just say okay.
Okay, yeah, don't forget that. That's very important. I hate to take half points. Okay. So the null hypothesis is as what is on the claim statement. Unfortunately, the claim statements is use the word contradict, so you cannot copy and paste in your null. So you have to kind of like change it. So anyone knows where's the opposite of the word contradict?
Oh, wait, you say what's the opposite of contradict? It goes together.
So agree.
Yeah, it's agreed.
So yep. So so in this case, it will be the results agree with Mendel's theory. And if you say, David, I am not an English major, I do not know what is the opposite of contradict, then you say that the result do not contradict.
Oh yeah, yeah.
So you just use the word do not or no or something else. So if you doesn't know the opposite of words, you know, don't worry about that. I'm not, again, this is not an English class. So you just use the word do not. Okay. But the alternative is the result contradicts, the results contradict Mendel's theory in this case. So make sure, what I really want you to know here is make sure that your null hypothesis is equal and the alternative is not equal. That is what the main point of this, you know, of the test here. Okay. The sample distribution is chi-square. Again, I don't have the. I'm gonna write it out because I can write it out in here. So I think I teach you how to write chi-square. Just write the 2c and like form together and then square on it. Otherwise, if you want to be more fancier, you just do a little curvy on the first one, and then the next one you just draw a straight line. So these are the symbol for chi-square. Or you can just put chi-square, like your RStudio did, CHISQ. Totally fine with it. I think I know what you did here. I think you know what you're doing. So again, these are the symbols for chi-square in this case. So those are the third steps in this case. Question. All right. Critical values. So that is the fourth step, which if you follow along the here, this is the critical value. So in order for us to find the critical value, you have to do number 27, which is the q chi-square 1 minus alpha k minus 1. So this will give us q chi-square. This is what happens to my computer sometimes when I type something. It's not. Oh, no. Ooh. Okay. So I told you my. Okay, I will do that again. So fourth step is doing a critical value. I'm sorry, just not my kind of day today with the computer here. Critical value. You will do q chi-square 1 minus alpha, and alpha in this case is 5%, 0.05, with k minus 1. K in this case is how many groups do we have? Since this question has 4 groups, yellow, smooth, green, smooth, yellow wrinkle, and green wrinkle. So this will become 3. Okay, just want to point out to you guys. 4 minus 1 is 3. And then you just go into your RStudios to do this. So q chi-square. So just type in q chi-square 1 minus 0.05. And then 3. That will give us 7.81. 815. Again, I'm not picky about how many decimal places. Make sure you know how to do this in your RStudios. Okay. Then step number 5, you have to find the p-value and the test statistic. Okay. So in order for you to find this, you need to use again your RStudios, where your counts will be the observed frequency and your probability is those probabilities. Okay. So I'm gonna pull up my RStudio here. Move it down a little bit here so we can see. So first, your counts, which is if you refer back to your number RStudio cheat sheet or the previous page, these are the one that you type in here. So counts in this case is C, and then you put in the counts 307, 77, 98, and 18. Okay. And then probability equals to C. Okay. And then 9/16 for the first one, 3/16 for the second one, 3/16 for the third one, and 1/16. And then you do the chi-square test. Yep, this one. And then you do counts, and P equals to prop. So this is the last statement you're going to do. Chi-square test, counts, P equals prop. And you will get yourself, the test statistic will be the chi-square value given in the question, in your RStudio here, which is 11.161. And the p-value is the 0.01089. And if you doesn't know, the degree of freedom is 3 from finding the critical value. If you doesn't know this, it's also given right here. So make sure you guys, you know, this given 11.161. And the p-value is 0.011. Right there. All right. And then, so this is step number 5, which is the extra step due to the critical value that we find. Decision is the same decision that we'll be doing the whole time. You're looking at your test statistic, your p-value and your alpha. You notice that your p-value in this case is less than alpha. because this is 0.011, alpha is 0.05. So this number p-value is less than that. And for that case, we will reject the null hypothesis. Okay. And then now this is a very special case that I'm going to bring it up here. So conclusion. Okay. Now, this is very special, so pay attention. As you know that when you draw a conclusion, you got 1, 2, 3, 4, if you remember the conclusions table here. And you only draw the first two if your claim statement has not include equality, means that it is either less than, greater than, or not equal to. So this means you're doing this, okay, for conclusion number 1 and 2. And then for conclusion 3 and 4 is where your claim statement has equality. So if this is, so what we did here is, if you read this conclusion, the original claim statement, it says that the result contradict Mendel's theory. So that means that your claim in this case is not equal to. As you know that the word contradicts means not equal to. And based on step 6, you are rejecting the null hypothesis. So does anyone know which conclusion should we take? Number 1, 2, 3, or 4?
Is number 1.
We are taking the first conclusion. I'm going to put this in parentheses here. So we hardly do anything that has not equal to. Usually is less than or greater than or equal to in chapter 8 and 9. But for when you reach into these back chapters, your claim statements can be not equal to. And don't forget, for the if you pick the first two one, it can be less than, it can be greater than, and it can be not equal to. So that's why this is very special. And since we reject the null, we will pick the first conclusion here. There is sufficient evidence to support the claim. Okay. So so this conclusion will be there is sufficient evidence to support the claim. So I just want to point out to you that it can be that way because of but not equal. Okay. Supporting that, then you just write down the claim statement, the results contradict Mendel's theory. So if you write this, that means that yes, Mendel's theory is wrong. Okay, so if you get observed frequency of 307, 77, and 98 and 18, this result does not match with Mendel's theory, or does not agree with Mendel's theory in this case. So when you write this means your claim is valid, but as you know that validity of this claim means that the Mendel's theory is rejected. Okay. So again, the word contradict is a negation word. Just want to point out to you. Remember, I show you some negation word, and contradict is one of them. Okay. A little bit tricky here due to the what we have. And then we have the last one question. So what other factors will change the outcomes of this claim? So again, the factors usually in the test, I ask you for one, don't give me more. So this is talking about plant or peas. So then you can think about what factors will affect the plants from growing this kind of peas. It can be
the weather.
The weather, yep. So where do you put this plant? Is that outside the sun or inside a dark room, or there is a lot of factors you can add on. The weather is one of them.
The soil. The soil.
The soil, yes. That means, is that fertilized or not fertilized? What kind of, are you using sand? Are you using what kind of soil are you using? So there's a lot of other factors that you can give to me, and looks like Pamela got those. You guys okay here?
Yes.
Yep. So sun, water, there's a lot, right? That you guys know plan quite this kind of require this kind of necessity to grow. So those are the factors that we talk about. Questions? So this question is where they give you ratios, okay? And the first question, they give you exactly probability, or in this case, percentage. You do not need to change anything. This is where they give you probability. And we will do the last question here before we move. Does everyone have any questions before we go to question 3, the last question? Okay. Data set 6, birth include the days of the weeks that prospective mothers were admitted to a hospital to give birth. And here comes a physician claim. So the claim statements here is that because many births are induced or involve cesarean sections, they are scheduled for days other than Saturday or Sunday. So births do not occur on the same different days of week with equal frequency. So this is the claim that the physician says. What does that mean if, you know what, they found out that a lot of, this is for giving birth, a lot of prospective mother who wants to give birth, found they usually give birth on Saturday or Sunday because those are the days that the husband get off, or there's no work, and it's better to give birth that day so the they can walk, they can help, the husband can help. So so what they say that you know what, it's not the same thing. So that means that what the physician claim is like, you know what, if the mom has to give birth, it has to give birth. Doesn't matter, it's Monday, Tuesday, Wednesday. So the birth does not occur on the same 7 different days of the week with equal frequency. Now, again, the word do not occur, you really know that this is equality or not equal to?
Not equal to.
And then on top of it, they have this big keyword here, equal frequency. Okay, so you don't see that in question 1 or question 2, because question 1 gives you the probability or the percentage. Question 2 says the ratio is this to this. When I ask for equal frequency, means that Monday, Tuesday, Wednesday, all the days are having exactly the same, probability. You're correct. So I would say that. So that means that if you want to do probability of, I just say Monday, it's the same as what? Probability of Tuesday,
Thursday, Friday,
Wednesday, Thursday, Friday, Sunday, which is the same as what? 1 out of 7. Okay, because there are 7 days in a week, right? And one of them is 1. So that's so make sure you guys know when they use the word equal frequency, they don't provide you the probability or the ratio. So you have to know that it's 1 out of how many days or how many categories we have. Since we got 7 categories here, so it's 1 out of 7 in this case. Okay, and you have to use a 0.1 significant test to test the claim. And then here comes the question: is a physical claim being true? In other words, this question is asking, is the claim statement valid or invalid? Okay, that's what we call. And as usual, we're gonna build that table of yours here. So we're gonna do Monday, we're gonna do Tuesday, we're gonna do Wednesday, Thursday, Friday, Saturday, and Sunday. We'll put a little bit further away here so that we can put down. So first thing first is you have to do the observed frequency. Usually the observed frequency is given in the question, like, how many this group, but because we're using data sets here, so you have to use your data set in this case. So this is observed. I just put O so you guys know that. So go to your RStudios. We're gonna import data set number 6, birth, into your RStudio here. Great. So import data set from Excel. I need to find where's my data set at. I think I kind of know where is it at. Correct. Nope. Data, there you go. Number 6, birth. And then you guys know that I've changed a name. Instead of using X06 birth, we just use birth in this case. Take a little bit while because they are receiving data. from the cloud. Come on. It's that long time. Okay, there you go. Okay. And these are all not important. Admitted. This is the one that is important because this is the one that the moms was admitted to the hospital. Okay. And discharge means the mom left the hospital. So those are the days. The rest is, so we're going to do that. So so we got the birth in this case. Again, we are only do admitted. So I'm going to put a variables for it. Let's say days. If you want admitted days equals to birth. Money sign admitted. Okay. So now if you type in days, these are all the days that the moms got into the hospital. Now I'm not gonna call you to tally up how many Fridays, how many Wednesdays, how many Mondays, and so on. So in order for you to tally up, you just do the tables in this case. So just type table days for that case. Okay. So again, they are not arranged nicely like what we want, so but you can still manage to get the days, the frequency, the observed frequency here. So on Monday, I'm going to be smaller so I can see do two tables here. So Monday in this case will be 52. Tuesday is 66. So when you type in the RStudios, when you use the word table, means they kind of put you guys in table. So this is mostly what we're using quite a lot in this case. Wednesday is 72, 66 on Thursday. No, 57, sorry. 57 on Thursday. Friday is also 57. Saturday is 43. And Sunday is 53. Okay, so this is your observed frequency. Again, came from your RStudio. P stands for probability because they are equal frequency. That means it is 1 out of 7 for each case. Okay, so again, all 1 out of 7. And then we need to find the expected frequency here. So let me put down all this in a table form here. I put E for the expected frequency. So I just make, in order for you to find that, you need to figure out what is N here. So you need to use your calculator to add all these numbers up. Or you can just add all this number up. Or if you look at this, and we got 400 entries here. So we kind of know that N in this case is 400. But if you want to double check everything to make sure it is 400, you just add those numbers up: 52, 66, 72, 57, 57, 43, and 53. Yep, you get 400. Just sometimes I do that just to double check if I copy or write something wrong. So to find the Monday one, you take 400, which is N, times 1 divided by 7. Is around 57.14. Okay, so this expected frequency will be 57.14. And the good thing about if they are having the same frequency is if they're having an equal frequency, means the expected value is also the same. So this is also 57.14. I'm going to use the dito sign here. I'm lazy to, so you guys know what it means. It is, I just put the word same. Oh, you know what? 50%. Well, I'm just, so every single one is the same. So that means your expected frequency is also the same. Is everyone okay here so far? So good?
Yes.
And give a kind of like a task for you guys. What happens if you add all these expected frequency? When you add 57.1, what you get when you add all these up? You will get...
It gives, well, approximately 400.
Yes, you will get 400. So if you add all your expected frequency, you should get back N. Same thing happens here for the P's. If you add to this 4 expected value, you should came out to be close. It should be is 500. Okay, so that's what it is. And what is expected frequency? We are expected how many Mondays show us on Monday. 57 mothers will show up Monday, but actually 52 mothers show up on Monday. And Tuesday, also 57 mothers, but 66, and so on, so on. Okay. Questions? All right, so the first question, then we go up to the SRS here. The first one is the requirements. Sorry, the first one is SRS. This one is good because it comes from a data file. So as you guys know that all data files SRS. Second one is every category has
account.
Account. Yep, thank you. And that one is also yes, or check in this case. Yes, check is the same thing. Because you can tell that every days has a mother comes in. Okay. And the last requirement that you need to check here is the expected frequency is yep, greater than or equal to 3, greater or equal to 5. This one is also yes, because every single one is 57.14. So in this case, your requirements will be met in this case. Okay. 2. Now, I'm lazy to write because if you look at the physician claim, is a long claim statement, but we just need to write down that claim statement that I highlight in yellow. So again, unfortunately, that is not in the now because it is has the word not equal to, or has the word not. So anyone know what to write for your now hypothesis for question 3?
Is it birth do occur on the 7 different days of the week with equal frequency?
Yep. So yep, you're correct. Just stick up the word not. Birth do occur on the 7 different days of the week with equal frequency. Now, the alternative, again, because you write a lot here, you can use the ditto sign, and then you just put the word do not occur, and then ditto sign, okay? In the test, I allowed you to do so because of time consuming, but do not do that in your project. I think you can copy and paste stuff like that in your project. So make sure you guys know that, okay? So next one is the test sampling distribution. So that is chi-square, okay? And then the fourth one is the critical value, okay? In this case, we will do 1 minus alpha, but our alpha in this case is 0.01. The degree of freedom in this case is 6 because we've got 7 days. So 7 minus 1 is 6. Then you will have to use your RStudio to figure out what is this value is. Q chi-square of 1 minus 0.01, or you can put 0.99. 6 is the degree of freedom here is 16.81. Okay, so that is your critical value for question number 4. Okay. Step number 5 is do test statistic and p-value. Okay. Again, in order for you to do that, you have to type out that 3 lines here. So start with counts equals to C. You're gonna give me all the counts here. Now, do not if you want, you can do the counts, because if you want, you can do the table date, because this table date give you all the counts. But if you, I would just say, just type it in 52, 66. I think you can do that. I will try it the next 1, 2, 3, 4, 5, 6, 7. Yep. Probability equals to C is 1/7 across the for 7 times. One, 2, 3, 4, 5, 6, 7. And then you do the count, you do the chi-square test. Okay. So the test statistic will be 9.5 with a p-value of 0.147. You guys doing okay here?
Yes.
I'm gonna see if I can put down as table day here. Just, I think it should work. I'm just checking this. Yep, it should work. Yep, so you can still use table day because as long as the frequency is the same, because then doesn't matter they put Monday first or Friday first or what day first, they're all gonna have a 1/7 for each cases. So you can do that way. You can do count seed table day and then so on. But if they are not having an equal frequency, then I will recommend you to do the first thing. Means Monday, Tuesday, you have to line up nicely. Questions? Unfortunately, for decision is your p-value we have here is not less than alpha. Your p-value in this case is greater than alpha. We will fail to reject the null. 7 is a conclusion. And then now we will look again back to your original claims question here. Since your original claim question, it does not has equal sign, which is the word not equal to, and we fail to reject your null hypothesis. So are we doing number 1, number 2, or 3, or 4 here?
No, then that's number 2.
Yep, this will be number 2, and it's again due to because of the original claim does not have equality. So it's either 1 or 2, but since we fail to reject, it's going to be number 2. And for number 2, the conclusion says there is not sufficient evidence. So there is not sufficient evidence to support the claim that copy from the birth do not occur on the 7 different days. Please do not change the claim statement, because if you change your claim statements, you might get wrong here. So please just copy and paste that. With equal frequency. Okay, so if you say that means that this claim statement says that it is the physician claim is not valid. Okay, so so in this case, in other words, that this is question 8. The physician claim is not valid. Okay, so that means that it is not the same. That means that it is the same. So since this is not valid, again, you got double negation, the word not and the not, so we'll cancel out. That means birth do occur on the same days. That means that based on what we have here, the birth, that means every single birth occurs on the same frequency. Although you say, no, David, look at Saturday, only 43. And look at Wednesday, more moms turn in. But again, when you do in statistic, we don't point out the low and the high. We especially when you do hypothesis testing, you look at this as a whole picture. Okay. So that's the reason why that when you guys do this, and you'll be like, oh, this is small, this is high, right? But again, we look as a whole picture. We don't point out who is low and who is high. So, but there are a few days like Thursday and Friday smack right 57. Sunday is a few less, and then Monday is a few less. So it's for this case, if you got just a few, again, data is not perfect. So that's why this the physician claim is wrong, because it is actually the mom came to birth on every day is the same day. Okay, same frequency in this case. You guys, okay, what I'm trying to do here?
Yes, we got it. I mean, I got it.
It's kind of difficult, but again, you're exposed to the steps of hypothesis testing, so I'm not worried about that, and you kind of know what to do. This just a new new sampling distribution, which is chi-square. I also will tell you that again, when you continue taking statistics class, when you're performing these hypothesis testings, it is the same 7-8 steps of hypothesis testing, no change. It's just a different sampling distribution that you do. Okay. So that's why I major in statistics, because I kind of see that pattern over and over, repeat again. Then you just need to figure out the main part is which test goes to who. Okay, that's what I do it. Okay. This homework is due on next Wednesday, which is the 3rd. Okay. So you have time to play on it. I didn't assign a lot of questions in these last 2 chapters here because you have to do a bit of work involved. Okay, it's not just something something quick. Okay. Questions before we hit 11.2, contingency table.
No question for me.
Julian's okay. So, okay. So what is the difference between 11.1 and 11.2? Yes, 11.1 is called goodness of fit test. 11.2 is contingency table. So what is the difference? Okay. So let's bring back that mother born on that days. So if you just do Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then you got the observed frequency, this is not contingency table. This is not 11.2. This is goodness of fit test 11.1. The reason why is you only have one categorical variable, which is the days, right? When you have a contingency table, then you will have 2 categorical variables. One is the days, and one is, let's say, the race. So now you got the white, the blacks and the Asians and all this race. So now you will get yourself a more even detailed table, or this is more we call it as. So this table is called contingency table, where you will get yourself 2 categorical variables in this case that is having more than 2 choices. Okay. So last time you got 1 categorical with multiple choices. Now you got 2 categorical variable that got more than 2 choices. The category in this case are race and the days, Monday to Sunday. And then now you just say 5. So this 5 means that there are 5 mothers, white mothers who was get to the hospital on Monday or born the baby on Monday, something like that. So, and so on, so on, so on. So that means this, in order for you to do this, you have to refer back to 11.2. Okay. You guys all right with this difference between these two?
Yes, we have to understand later.
Yes. So what is a contingency table? It's a table that consists of accounts on categorical data that have 2 different variables. When I say 2 different variables, in this case, it's your race and the number of days here. What days is it? And then one variable used for category rows. One will put in rows, and one of them is put in columns. So again, you need to know the difference between rows and columns. Okay.
So I guess here the dates are for the columns and the race are for the rows.
Yes. So this is called the row. So row is always go left and right. So this is called the rows. Okay. The columns always goes up and down. So this will call columns. I put R and C for rows and columns again. So make sure you guys know that the rows in this case is the race, and the column in this case is the days. What day is it?
The days, yeah.
Okay, so make sure you guys know this, very important piece. Again, if you switch things around, if you switch your race and your rows and your columns around, there are some, your test statistic is changed, but your p-value is still remain the same. Okay, so just want to point out to you that if you switch your rows and your columns around, your condition table looks a bit different, but your p-value is still the same. The most important, if your p-value is the same, then your decision and conclusion all stays the same. Okay, so that will be the good news. It's just that test looks a bit different. All right, so what can we do with this? Okay, what can we perform? What kind of tasks can we perform if you have a contingency tables? We got two types of tests. We can do tests of independent. This is number one. And we can do what we call as the second one, the test of homogeneity. Okay, so there are two different types of tests you can do for a contingency table. Okay, so let's talk about these two tests. What is test of independence means? The test of independence is where the null hypothesis H0 of the contingency table here, it says that the row and columns are independent. So what it means by independent? Independent means these two variables, the race and what kind of days, has nothing to do with each other. Okay, so let me repeat. When you say the rows and columns are independent, means that the row and the columns variables are nothing to do with each other. Like the word independent, like male and female, they are independent because either you belong to male, you belong to female. That means there's no dependency in this case. For a dependent case means that these two rows are the row and the column has something related to each other. Okay, so test of independence is only testing if these two rows and columns are they independent or are they not, or they dependent. So I will point out very easy null hypothesis is the row and column variables are independent and the row columns are dependent for the alternative hypothesis. Straightforward type here. And again, make sure you know that when you test for row of the row and the columns at independence is for equal sign, and this is for not equal sign. Again, we don't do less than and greater than for this case. Okay. So again, we have all this OERT in this case. O in this case is again your observed frequency. Okay, and again, this is exactly what we just did for the previous section. This is from the sample. Okay, usually given in a question or the data. Okay, so this is the one that we just mentioned, like the mom, this one, the 52, 66, 72. These are observed frequency. Same thing with the P's, the 3077. So this means it is a result from an experiment or result data that is collected from an interview. Like this 5 is, that means I collect data that 5 white moms that give birth on Monday and so on and so on. So these numbers are what we call as observed frequency. E in this case is called an expected frequency. This is where we expecting to get. There is a formula to do this. If you remember last time, the formula to find your expected frequency is N times P. But the formula to find this is a little bit difficult. Not difficult, it's just a little bit more. Which is row total times the times the column total divided by the grand total. And yes, this is something that you need to memorize for your test, or I would say put it into the cheat sheet to memorize. So yes, I will, again, when you come back on Monday in class, I will give you a blank piece of paper, and then you begin to write down the formulas that you need to know for your finals. Don't forget, chapter 7, 8, 9 that we did last time for your test 2 will be transferred. So that means that take up your test 2 formula and then add more on it. That means that will be used for your finals. In other words, make things easy, right? So this will be the formula to find your expected value. And the formula is, I will show it to you here. It's the same formula that we just, the row total times with the column total. Yes, I will show you how to do this. And then divided by your grand total.
Okay. The grand total, is it the total of the rows total and the column total?
Yes. So if you total all the rows and the total and the column total, that's a grand total. In this case, your grand total is n.
Doesn't that mean that for each expected value from each of the
yes,
it's going to be the same, right?
Yes. So when you do this, means you figure out what is the if you look at this contingency table, you figure out what is the expected frequency for white moms who born the baby on Monday, white moms who born the baby on Tuesday, and so on and so on. That means every single cell that we have here, you have to figure out the expected frequency for each one of those.
And I guess that will be the same.
Yes, that will be what we are trying, either the same or they're not the same.
Oh.
That will be, well, you know, again, we only do equal, not equal to, so we don't do less than greater than.
Okay.
And so this will be your row total. I'm gonna put in different colors so you can see it. This is total for row. So you will add all these numbers, and that will be the total for the white race, and that will be the row. And if you add, that's purple. If you do the orange one, if you add all, green, let's do green. If you add all this column, this will be the total of the column. So this total will be your column total. Okay. And then for the grand total is the total of all them. So if you take, what color should I use? Orange. Let's do. If I do the total of this and the total of this, so you can find what is the total, the star here. This is your grand. So you take total of all this, or total of that all. When I say you can add this, or in other words, the grand total is your n. That means how many people are surveyed. That means how many people participate in this study. Sample size in this case. You okay there? You will see an example. Okay. So R.
It's a little confusing here.
Yep, it is a little bit. R in this case is the row categories. That means how many choices that the row has. So if you have white, black, and Asian, then your R in this case is 3. But if you have white, black, Asian, Hispanic, and so on, so on, so on, then you figure out how many row choices do we have. C in this case is your column choices, or column categories, or column choices. Since for this case we got Monday till Sunday, so C in this case is 7. Okay, so so make sure you guys know there's a R means that how many choices do a row has, or how many variables, how many yeah, I say choices in this case, so easier. Requirements, again, SRS is the first requirement. Make sure that your data can be represented as a two-way table. What is two-way table? A two-way table is a contingency table. Okay, so sometimes they use the word two-way, but which is a contingency, which just means that your table has to be this, where it has cell on it. It means you got broken down into a table like this, not the table what you learned in 11.1. Okay, and the last requirement is make sure the expected frequency is at least 5. So don't forget, this time you have to do quite a bit. If you have this, you got 1, 2, 3, 4, 5, 6, 7. 7 times 3. So you have to do all 21 expected frequency. And you have to figure out all these 21 expected frequency has to be at least 5 on each cell. Okay, so 5 on them, this, and so on. Again, I won't give you this in your test. You won't see this in your homework because there's no way I'm going to call you to 21 expected frequency. I will probably keep it a little bit short. So in the test, it's usually like maybe 4 columns and 3 rows or something. That means 12. Means you cut this by half. I wouldn't give you more work. Again, because of time constraint, you don't have time to do all those work. But when you go on to the, a big project in your, if you work for your statistics career, oh yeah, you will get more than those bigger contingency tables than what we learned here. Okay. So again, it's not a requirement for observed frequency to be at least 5. So what it means that the expected frequency to be at least 5 doesn't mean the observed has to be at least 5. Let me just point out to you what does that mean here is, when I say expected frequency at least 5 means that E has to be, the value for E has to be 5 or more. It doesn't mean that your O has to be 5 or more. Okay, there's no requirement says that your observed frequency O has to be 5 or more, but there is a requirement saying that your E, expected frequency, has to be more than 5. Okay, so make sure you guys know the difference between observed and expected. So that, I'm sorry?
I have a question.
Mm-hmm.
So for those requirement here, the part that say every category has a count, I guess that part is about the observed frequency, right?
Yes.
Okay.
Yep. The count is the observed frequency. So make sure that yeah, let's put it this way. This is your count. Yep. So observed frequency is your count. So that means that, in other words, there is no requirement saying that the count has to be at least 5.
Okay.
Okay, there's no requirement. Okay. And there is also no requirement stating that the population has to be normally distributed and so on, so on. So in other words, you don't use CLT here. Okay, remember, CLT needs normal distributed and more than 30 and all those things. That means again, CLT is only used for mean or categorical variables. This is mean, which is quantitative variables. This is all categorical variables. So that's the reason why that we do not use that here. Okay. Same thing with proportion. When you guys learn in chapter 7 and 8, we don't talk about CLT when we do proportion because it is categorical type. You only do CLT when we talk about mean, okay, or quantitative type. Okay, so just want to point out for you. So test statistics, make sure you memorize this. Again, the only thing I want to point out for here is chi-square is our sampling distribution. You do not need to memorize the formula. The formula you need to memorize here is how to find the expected frequency, which is the row total times the column total divided by grand total. Okay. The degree of freedom for this case is R minus 1, C minus 1. You do not need to memorize that case too, because it is written down as your in your RStudio cheat sheet. You can find right here, because every time when you do your your Q chi-square, this last number is your degree of freedom, which is R minus 1 times C minus 1. Again, you just need to know that. And again, if you ask for the degree of freedom for the first one that you do, the goodness of fit test, the degree of freedom is K minus 1. So make sure you guys know, if you want to figure out what is the degree of freedom, go to your critical values formula. They will show to you what is the formula for that. And again, to find the critical value, since we are using chi-square, we only do a right tail test, no matter it's not equal to, it should be a 2-tail test. Then for us to find it is Q chi-square 1 minus alpha degree of freedom, which is R minus 1, C minus 1, which is again found in number 28 in your RStudio cheat sheet here. I will put number 28 here, so you know that this is from 28. Okay. So how do you find the test statistics and the p-value? This time you have to begin to do a matrix. So in RStudios, we don't do a table, we do a matrix. So how do you do a matrix is X equals to matrix. So because it is, so when you put yourself in a contingency table, it is kind of like a matrix type. So you will do C parenthesis C equals to A, B, C, D, E. Now this A, B, C, D, E, this is the most important thing you need to do, is where you put your count or your observed frequency. I'll put an O in this case. when you read down. Okay. What do you mean by read down in this case? So let's say you got this 5 and 3 and 8. Let's say I do just a little bit here. Let's say I omit this for time consuming. 10, 1, 8, and then 7, 2, 7, 17. Example. So when you put the first, how do you put down the matrix C, A, B, C, D here? A, B, C, D is a number here. Make sure you read the matrix down, the count downwards means you do 5, and then 10, and then 7, and then 3, 1, 2, and then 8, 8, 17. So when you do this, I just want to point out again, you read it downwards like this. Okay, so that will be, this is how you read your ABCD here. And then NCOL, it stands for number of column. That means you have to tell our students how many columns. Don't forget, columns is this. So if I write this, that means you got 4 columns. This is 5 columns. So that means NCOL equals to 4 or 5. 2 means you got 2 columns. So so make sure you guys know, first, make sure you read down, and then make sure you know that you also need to tell how many columns. Then I want you to do the X here. The reason why you do your X here is to check if the matrix that you built is the same as the contingency table given the question. Okay. And then the last thing you do here is given the question. Then you do the the chi-square test, X correct equals to false, and that will give you the test statistic, which is given you chi-square is a test statistics. And then they give you the degree of freedom and the p-value. Like exactly what we just did on last time. They will give you the chi-square, DF, and p-value. Kind of the same as what we have here. Okay. This is all in number 28 in your RStudio cheat sheet, including this little count read downwards over here. Okay, so if you can see here, I copy everything and paste over there. So this is to read down, and then the number of columns. And then when I put X is to check the X matrix. So when I say checking the X matrix means you want to check if the matrix that you built here is the same as your contingency table given in the question. And then for that case, you do the chi-square test. So this is a test for homogeneity, the first one. Okay. As you know that we also can do tests on the second test, test for, so this is test of independence, sorry, the first one. The second one, we also can do test of homogeneity. What is a test of chi-square test of homogeneity is? It is where the claim is different populations have the same proportion of some characteristic. Now, what do you mean by they having the same proportion? It means that if you do the Monday, Wednesday again, I just do 3 days, and I just do white, Black, and Asian. Just again, I do say for time purposes. What is test of homogeneity says? Test of homogeneity says that this expected value is the same as this, is the same as this, is the same as this, is the same as that. That means every single one of this is the same. Every single one. You with me here? And that is the meaning of test of homogeneity. Means that we think that the observed frequency is the same for each, for every, I mean the same proportion for every single group, single cell. Okay. The good news about doing test of homogeneity is that conducting the test of homogeneity is the same as doing the test of independence. It means everything you did here is exactly the same. The only exception that is different is your hypothesis statements is different. Instead of doing independent and dependent for the test of independent, for test of homogeneity is the different portion have the same proportion, Same proportion means these are all the same, and not the same proportion means that one of these is not the same. So that is the only difference between test of homogeneity, chi-square test of homogeneity, and the chi-square test of independence. Just your H0, your null and the alternative. That is the only different piece that is found in this case. The rest is going to be the same, means you will still use the same requirement. You still have to use the same test statistic chi-square. If you want to find the expected frequency, same formula. The degree of freedom is the same. Critical value is the same. You have to do a matrix and all these things in your RStudio to find your p-value and your test statistics and all. Everything is the same. In other words, the only difference is the statement is different for this case. Okay. So how do you know if the question asks you to test for independence or test for homogeneity? Read the claim statement. Okay. So if the claim statement is like example 1 is asking you for independent, then you use test of independent. So just read the claim statement in this case. Again, this claim statement is also independent. So we are doing test of independent. This question is not, you don't see the word independent, but you see the word same proportion. Then we are doing test of homogeneity for that case. So again, read the question really, really carefully here to figure out, are you doing test of independence or test of homogeneity? This is all based on the claim statement that you underline or highlight that I tell you to do so. So if you highlight that asking for same proportion, you are doing test of homogeneity. If the claim statement call you to do add these two independents to each other, then we're gonna do the test of independence in this case. So this is as clear as that. Again, it's all based on the claim statement, as I mentioned, every time you do your hypothesis. Questions before we just start with the first question here, or first example? So this table below summarizes the success and failures of when subjects use different methods when they try to stop smoking. The determination of smoking or not smoking was made by 5 months after treatments began. And here is your claim statement. The claim statement is smoking or not smoking is independence of the method used. Okay, methods in this case used is nicotine gun, nicotine patch, or nicotine inhaler, and you have to use a 5% significant level. Okay, so the first question A is you have to find the expected frequency. Before you find the expected frequency, you have to give me your total. Again, there are 2 totals in this case. You have to find the total that it goes left to right. So this is called the row total. And then you also need to find the total that goes up and down. That is called a column total. And then you have to add all the row totals. That will be what we call as your grand total. Okay, so this is first thing we do first. So all right, let's figure those one first. So take out your calculator and add the row total for smoking. So it's 191 plus 263 and 95. So this is 549. What is this 549 total stands for? It means that is the people who smoke after they use these methods of quit smoking. Okay, so these are the total people still smoking after they use this nicotine stuff. Okay, and then for not smoking, you will do 59, 57, and 27. So 143. So these are the people, we call it quit smoking or not smoking after they use the nicotine methods, either gum, patch, or inhaler. So 143 people quit smoking, or in this case, not smoking after they do that. And then 549 still smoke in this case after they use that. Okay, so these are called the row totals. Okay. And then we have the column totals. So column totals, you just add this numbers column in the column. So it's 191 and 59. So 250, I'll put right here because of no place. And then we do the same thing for the nicotine patch, 263 and 57, 320. And then 95 and 27, this is 122. So what is the column total? This blue, the green one, what is the column total? That means 250 people use the nicotine gum as to quit smoking. And 320 use the nicotine patch, and 122 use the nicotine inhaler. Okay. And this 191 means that those who use the nicotine gum, they're still smoking. And for 59, those who use the nicotine gum, they quit smoking, and so on and so on. So make sure you guys know the difference between the column, which is the blue green, and the row, which is the purple in this case. Now we're gonna do the blue. This blue in called is the grand total. How do you find the grand total? Is just adding either the row or you add the column. Just one, or just need to add one of those. Don't add everything. So either it's 549 plus 143, which is 692. Or you can add those number up, 250 and 320 and 122. So you should get out 692. So again, you only add the row totals or the column totals to get your grand total. And this 692 is your N. That means that there are 692 people, they survey 692 people, sample size in this case. Questions? Okay. So again, the formula to find the A, which is expected frequency, is row total times the column total, or divided by the grand total. Okay. Now, how many of the expected frequency you're going to do for this question? You just count how many cells. There are 1, 2, 3, 4, 5, 6. There are 6 cells. You're going to do it 6 times. And usually, as statisticians, they write the expected frequency next to the observed frequency. Okay. So in order for you to find this expected frequency, you take those who smoke, the total of people who are smoking, 549, times those who use the nicotine gum, 250, and then you divide this with the grand total of 692. Okay, so let me repeat again. How do you find the expected frequency for the first cell, which is nicotine, those who use nicotine gum and smoking, still smoking? The expected frequency is taking those who smoke, the total people who smoke, 549, multiply with those who use the total of nicotine gum, 200, the column, 250, and over by the grand total divided by 692. And this is 198.34. You guys okay here?
Yeah.
And you're gonna do this for
6.
all 6 of those. Yes. So let's do the not smoking. It's up to you what you're gonna do, but you have to do all 6. Let's do the not smoking first. So for not smoking, the total, those are not smoking, is 143. Times those who use the nicotine gum, because we're still in here, 250. Divided by the grand total of 692. So this is expected for those who are using nicotine gum but quit smoking. That is 51.66. This is expected. So I expected this many people to be in this room. You guys all right? And then we do the same thing for the next one, the next column, nicotine patch, those who are smoking. So smoking is 549. Those who total people smoke, total people who use the nicotine patch is 320. And then you divide by the grand total of 692. So I expecting 253.87 of people who use the nicotine patch and they still smoke. And then I'll do the bottom one. Those who not smoke or quit smoking is 143. Those who use the nicotine patch is 320, and you divide by 692. So expecting 66.13 of those people who use the nicotine patch, but and they quit smoking. And you do the last two. The last two is those who smoke, 549 total. Those who use nicotine inhaler, the total is 122. And you divide this by 692. So this expected to be 696.79. And for the last one, you do the same thing. Those total who do not smoke, 143. Those who use the nicotine inhaler, 122, multiply them, and then divide this with a grand total of 692. 25.21. You guys all right here? How you find this? And these are called expected frequency. You guys okay?
Yes.
This is definitely coming up in your finals. Without finals. Question B, they ask you to figure out what is the degree of freedom. So the degree of freedom is you take R minus 1 times C minus 1. Again, you can find this in your cheat sheet, RStudio cheat sheet right over next to it. Okay. Again, how many rows do we have? We got, so row in this case is 2, but we got either smoking and not smoking. And how many columns do we have? We have 3. So now you plug this into this formula. 2 minus 1 is 1. And then 3 minus 1 is, don't forget, orders of operation. You have to do the inside the parentheses first before you multiply. Okay. So again, you are replacing, you plug in R is 2 and C is 3 based on the rows and columns we have in here. What is 1 times 2?
2.
2. So this is your degree of freedom. So in order for you to figure out what is, then the question also wants you to figure out what is the critical value. This one is completely coming from your RStudio. Q chi-square 1 minus alpha, the alpha is 5%. And the degree of freedom in this case is 2, which is the one that you just found. So you just hop into your RStudio and you do Q chi-square 1 minus alpha 0.05, and then degree of freedom is 2. So you will get 5.99. Part C, you have to find the test statistics and the p-value. So in order for you to do that, you have to use number 28. You have to build a matrix. Okay. So again, this is all number 28 here. So same thing with this one. You have to use number 28 in your RStudio cheat sheet, which is this friend of yours. Okay, and then this is the RStudio, what happens to my, okay. So so this case, first thing is you build a matrix for your RStudio here. So so make sure you put X equals to matrix. It's an X, not C. Okay. Thing is, then open your parentheses and then C, and then opening another parenthesis. So C means numbers. And then when you put this into your RStudio, That's my little notes here. There you go, my table. Make sure you read downwards. Don't read across, otherwise you get it wrong. So the first number is 191, comma, and then 59, and then 263, 57, and then the last two numbers are 95 and 27. And then close your parenthesis, just your first parenthesis, put a comma, and then you put end call. End call means how many columns do we have? There will be 3 columns. Okay, we got nicotine gum, patch, and inhaler. Okay. And once you put this, once you type this matrix out, just press X equals 2. That means this is to check that this matrix that you built is the same as the contingency table given the question, which in this case, yes, they are exactly the same numbers. If you got different numbers, don't use don't do the next step or the last step. And the last step to do this is you do the chi-square dot test x comma correct equals to false. And don't forget the false are all in caps. Cannot spell today. And then you get yourself the test statistic and the p-value here. So for this question, your test statistic will be 3.06, and your p-value is 0.216. And I just do E. Again, we are still chi-square distribution for this section. So no change here. Just undo E. Easy 1 point for you guys. And then you have to state the conclusion about this. Okay. And so first thing is you have to figure out what is independent. So independent belongs to equality. Don't forget, when you look at this, the statement here, our statement for independent is always equality. So when you hear the word independent, means we are doing equality. So since this p-value you found, is that less than or greater than alpha? And alpha is 5%.
Greater than alpha.
So we will what? Fail to
reject.
So the question wants to figure out what conclusion we have. Because the question has conclusion here. So what we do with conclusion, now don't forget this is equality. So your original claim has equality now, independence is equality, and you fail to reject the null hypothesis. So what conclusion are you picking? 1, 2, 3, or 4?
Number 3.
Should be number 4, right?
Oh wait, we failed to reject the number 4.
So again, when you hear the word independent, this is for equality. And we are failing reject this because our p-value here is greater than alpha. So we do number 4 conclusion. There is not sufficient evidence to warrant rejection of the claim that smoking or not smoking is independent of method use. So I think I'm going to type this out because I think I got time to do that. Okay. The conclusion will be there is not sufficient evidence to warrant rejection of the claim that smoking or not smoking is independent of the method used. So what it means in this case, it means that these two are independent. What I mean by independent means using nicotine gum, nicotine patch, and nicotine inhaler, and those who smoke and not smoking has nothing to do with each other. That means that if you try to if you try to prove to the FDA that oh, guess what? I think nicotine gum do better than nicotine gum and those who use smoking. The way that you use or 3 ways that you quit smoking using patch or gum or inhaler, has actually nothing to do with the smoking. Either you quit smoking or smoking. So that maybe there are some other factors beside using the gums. Maybe I do not know, social economy, race, or something else that might, might help or might change this outcome for either you quit or not quit smoking. But using different types of methods of quitting smoking has nothing to do either you're smoking or not, or you're quitting smoking. That's what it means in this case when you test for independence. You guys all right?
Yeah. Just have to study.
Yeah, it's not too bad. You haven't done the homework yet, so. And the last one is which hypothesis test are we using here? Right tail, left tail, two tail. We always use the right tail test. But wait a minute, David. Aren't you do equal and not equal to, right? Aren't equal not equal to is a two tail test? Why? This is a right tail test in this case. The reason explanation because chi-square is a right tail test, is skewed to the right.
It can never be negative.
Yep. Yep, you're right. Yep. Skew to the right.
Skew to the right.
And in other words, it never be negative. So that's the reason why that your test is always a right tail test. Okay. And then the sample distribution is chi-square, so that is E. So I'm gonna stop here now. So what we did in this question 1 is break up all the 7, 8 steps of hypothesis testing, although we didn't write down the statements and all these things. But the reason why I do this is because of MCQ. So you will see this kind of questions in your MCQ type, where I will ask you, I'll give you this table and I will say, what kind of test is this? A, right tail test, B, left tail test, C, two tail test, D, E, all these tests. That's nothing to do with that. And you have to pick the right tail test. Don't forget, all chi-square is right tail test. Okay. And the reason why is because chi-square is skewed to the right. It can never be negative. Okay. So that's the reason why that it is always a right tail test. You guys all right here?
Yeah, for now.
Yeah. So when you come back on next Monday, we will continue with question 2 and question 3, where this is the open-ended questions here. So mostly this one is kind of like a multiple choice question, except for A, when you find all this expected frequency, those will be in your open-ended question because you have to do some math involved. Okay. It's not going to be in the multiple choice here, but it will be open-ended questions. But the rest of this probably will be in the MCQ. But once you hit into here, you will get open-ended. And when you come back on Monday, those students who are not attending my class today, they will get a chance to, visit this again. So they will get to understand this contingency table for tests of independence and tests for homogeneity. Right. Well, that's it for today's class. Any questions before you guys go for your Thanksgiving break?
No.
Yep. Take care there. Be safe. I know it's gonna be rain and cold and snow a little bit. Just be careful.